Alright guys, today we're going to talk about what happens when we have a power over a power. So for example on number 1, I have x to the 5th over x squared. Since they have the same bases, all I have to do is subtract the exponents. So I'll take the exponent of the numerator, which is 5, and subtract the exponent of the denominator, which is 2. And that's going to give me a value of 3, which means my answer is going to be x to the 3rd. Let's try it again on number 2. I have an a to the 7th over a to the 3rd. So I take the numerator's exponent and subtract the denominator's exponent, and I'm going to be left with a to the 4th. On number 3, again I have the same base, so I'm going to take the numerator's exponent and subtract my denominator's exponent. Now be careful, we have a negative exponent there. We're not going to move it first, we're going to wait till the end, and we'll be left with 4 minus negative 8. Now when I take 4 minus negative 8, minus a minus becomes plus a positive, and I'm going to be left with a to the positive 12th. So be careful. Take the numerator and subtract the denominator. Why don't you go ahead and pause the video and try number 4 on your own. Hopefully you get m to the 2nd, because 6 minus 4 is 2. Now on number 5, we are still working with a power over a power. Notice how the bases are the same, but the bases are numbers this time, which means we're going to have to get a final answer at the end. But until then, we're going to handle it just like normal. I'm going to take the numerator's exponent and subtract the denominator's exponent. So I'm going to take 8 minus negative 6, and that's going to become plus a positive, which will leave me 5 to the positive 14th. Now all I have to do is put that in my calculator, and when I do that I get a very long number. I get 6103515625. That's a very long number. So let's write it down and then put in our commas. So that's going to equal 6103515625. Then remember, we start at the end and we count 1, 2, 3, comma, 1, 2, 3, comma, 1, 2, 3, comma. Now that number is much easier to read. Our answer is 6,103,515,625. Now number 6 is when we have multiple variables that come into play, but it's not a big deal. We're going to take it one at a time. Let's start with the x's. They have the same base, so I'm going to bring down my variable. Then I'm going to take my numerator's exponent and subtract my denominator's exponent. So negative 3 minus 5, and that's going to give me a negative 8. Then I can look at these guys. I've got y to the 3rd over y squared, so I'm going to bring down my y, and then I take 3 minus 2, and I get a positive 1. Now, before I can say that's my final answer, I have a negative exponent. That's not okay, and I just have to move it. So the x term is going to have to go to the denominator, and the y value can stay put. So I'm going to have y over x to the positive 8th. On number 7, now they've thrown in coefficients in the mix. Now just a reminder, we treat coefficients just like normal. So I'm going to split this up so the coefficients are on their own, and then I'm going to look at the variables. You don't have to do this on every problem, but we're going to do it on the first one to get a better understanding. So if I were to write just the coefficients as a fraction, that would be 2 over 6. Now that would be multiplied by whatever comes after that, whatever's left, x to the 4th, y to the 3rd, over x squared, y squared. Now I can simplify it like normal. So I've got 2 over 6, which would simplify it to 1/3. Then I can handle x to the 4th over x squared, so I subtract those. And then your answer will always go in the numerator, and then you see if you need to move it at the end. So in my numerator, I'm going to have x, and then 4 minus 2 is 2, and then y, and 3 minus 2 is 1. Now you can leave your answer like this. I'm okay with that. But if you see the 1s going on and you'd like to get rid of those, you can definitely say x squared y over 3. Each one of those answers is fine with me. Whichever one you choose, just put a box around. Let's try it again on number 8. This time I'm not going to rewrite it. I'm just going to look at the coefficients first. So if I were to take 12 and have it over 3, 12 divided by 3 leaves me with 4. Then I have an x to the 1st power here and an x to the 1st power down here. Now, if I were to handle the exponents like normal and say that's x to the first over x to the first, which means that I need to take that 1 minus 1, which equals 0, that would leave me with x to the 0 power. And as we've talked about in the past, anything to the 0 power is just 1. So instead of going through all this work, let's just make it easy and say when the exponents are the same, we just cross them out. Now let's look at the y's. I have y to the 6th over y to the 4th, which leaves me with y to the 2nd power, so 4y squared. Now, what I'd like you to do is pause the video and do number 9 on your own. Hopefully you are left with negative 1 y squared z squared over 7, because this simplifies to negative 1 over 7. Y to the 7th over y to the 5th is y squared, and z to the 5th over z to the 3rd is z squared. Now in number 10, I've got a lot going on. I've got a fraction, and the whole fraction's inside of parentheses being raised to an exponent. And what I need to do with that guy is, when in doubt, you need to follow the order of operations. So I have grouping, exponents, multiplication and division, addition and subtraction. So the first thing I need to handle are grouping symbols. And to handle those grouping symbols, I'm just going to focus on what's inside of my parentheses first. I'm actually just going to ignore these parentheses and that exponent of 2. And I'm going to simplify this guy like though they weren't even there. I'm going to simplify it like I have been. So let's try that. So inside of the parentheses, I have 3x squared y over xy to the negative 2nd. So if I start with the coefficient, I only have one coefficient, which is 3, so I'm going to bring it down. Then I have x to the 2nd power over x to the 1st power. So 2 minus 1 gives me x to the 1st power. Then I have y to the 1st power over y to the negative 2nd power. So if you need to, you can always write it out. 1 minus negative 2, which will plus a positive and give me y to the 3rd power. Now that I've simplified that, I need to bring these guys back down because I haven't used them yet. They're still important. So I'm going to bring down those parentheses, and I'm going to bring down those exponents. So I've simplified my grouping. I've gone through and I've handled everything inside of the parentheses. Now I need to handle the exponents. So I need to handle whatever's on the outside of these parentheses. So I'm going to distribute that exponent of 2 to see what I get. So remember, 3 squared, I actually need to take 3 to the 2nd power and get 9. X squared leaves me with x squared. And then y to the 3rd squared leaves me with y to the 6th. Let's try it again on number 11. We're going to ignore the parentheses and the negative exponent until the end. We're just going to focus on what's on the inside. So if I simplify this, I only have a coefficient of 2. So that's going to come down for the ride. Then I have a squared over a, and 2 minus 1 is 1, so I have a. And then I only have 1b, which is going to stick around. Now I'm going to bring down my parentheses and my negative exponent. Now, negative exponents make things a little tricky, but that's okay. I'm just going to distribute that negative exponent to everything inside of my parentheses. So if I take 2 to the negative 3rd, I'm not allowed to do that, remember, because you'll get a decimal if you put it in your calculator as 2 to the negative 3rd. So we're just going to write it as 2 to the negative 3rd. Then I'm going to take a to the negative 3rd and b to the negative 3rd. Now I need to move some things around and figure out what I'm left with. So currently this is all in the numerator. So to get rid of my negative exponents, I need to move some things to the denominator. So when I move 2 to the negative 3rd to the denominator, it becomes 2 to the positive 3rd. When I move a to the negative 3rd to the denominator, it becomes a to the positive 3rd. And when I move b to the negative 3rd to the denominator, it becomes b to the positive 3rd. Now, whatever is left in the numerator needs to stay there. Well, nothing's left, which means it's just a 1. And then finally, I need to simplify this coefficient. I have 2 to the 3rd, and 2 times 2 times 2 is 8. So this is 1 over 8. A to the 3rd, b to the 3rd. On number 12, again, we need to ignore these parentheses in the exponents until the very end. I would like you to pause the video and try number 12 on your own. Okay, hopefully on your first step, you saw that there was only one x in the numerator. And then I have y to the third over y, which leaves me with y squared. And then if you'll notice, I have z squared up here, and then z squared and z to the first down here. Now you could go through this a couple of different ways. You could have added those two z's together first to get z to the third before you handled this, or what I would do is I see that I have a z squared and a z squared, and those are going to cancel out and just leave me with 4 times z in the numerator. Then I can bring down my parentheses and squared, and now I have to square everything inside of my parentheses. So x squared is going to leave me with x squared. Y squared squared leaves me with y to the fourth over 4 squared is 16, and z squared is z squared. On number 13, again, we're going to start by simplifying everything inside of my parentheses first. So 4/3 does not simplify. P to the negative 6th over P to the 9th, so that's going to be negative 6 minus 9. That's P to the negative 15th. And then R to the 4th over R squared leaves me with R squared. Then I'm going to bring down my parentheses and my exponent. But I hope you'll notice that this negative 15th isn't really great. So since everything else is simplified, you can choose. You can either leave this to the end or you can move it right away. I'll go ahead and leave it to the end to see what happens. So the first thing I need to do is I need to take 4 to the third power. And if you need your calculator, that's okay. 4 to the third power is going to give me 64. Then P to the negative 15th to the third, you multiply those, and negative 15 times 3 gives me negative 45. So I have P to the negative 45th. Then R squared to the third gives me R to the 6th. And then in the denominator, 3 to the third will give me a value of 27. Now finally, I need to move some things around. 64 over 27 cannot simplify. P to the negative 45th needs to come down to the denominator and become P to the 45th. And then R to the 6th can stay in the numerator. Alright, I'm going to have you pause the video and do number 14 completely on your own. Alright, when you simplify in the numerator, you should be left with 2r over w to the fourth, and that's going to be all to the fourth. Then when you take everything to the fourth power, you should get 16r to the fourth over w to the 16th. Now just be aware, I cannot simplify this because even though I have a 16 here and a 16 here, one is a coefficient and one is an exponent, so I cannot simplify them. Alright, on number 15, we're going to try it again. We're going to start by ignoring this and focusing only on the inside. So 3 over 2 cannot simplify. R to the 6th over R to the 7th. 6 minus 7 is negative 1. And then n to the third over n. So that's going to give me n squared. Then I'm going to bring down my parentheses and bring down my negative 4. Now, I'm going to try a different method here. Instead of distributing to everything, especially like we did on number 11 where I distributed a negative exponent and then moved everything, I'm going to see if I can get rid of this negative exponent first. So if you'll notice, inside of the parentheses, I have a fraction. And if you guys remember from the very first lesson of this chapter, if I have a fraction like 3 over 2, and the whole thing is being raised to a negative exponent, to get rid of the negative, I can reciprocate that fraction, and that can become 2 over 3 to the positive second. So here I have a fraction inside of my parentheses being raised to a negative exponent. Now this fraction is not going to change exponent-wise. Everything's going to stay the same. The only thing that's going to be different is I'm going to reciprocate it. So whatever was in the denominator is now in the numerator, and whatever was in the numerator now comes to the denominator. So 3r to the negative first n squared stays the same, 3r to the negative first n squared. Now the only sign that changes is going to be this guy. Since I moved everything around, this can become now a positive exponent. Now this is much easier to handle. I can take 2 to the fourth and get 16. 3 to the fourth is going to give me 81. R to the negative first to the fourth will give me r to the negative fourth, and then n squared to the fourth gives me n to the eighth. Finally, I can just move some things around. This is a negative exponent, it needs to move up. So I'm going to have 16 r to the fourth over 81 n to the eighth. Now, whichever method you're more comfortable with, if you're more comfortable with distributing that negative exponent and then moving, go for it. If you'd rather get rid of the negative exponent first, that's fine too. Now let's look at number 16. Normally on these problems I want you to ignore the variable, or ignore the parentheses and the exponent and focus on the inside first. But on this one, this exponent is really, really important. Since I have an exponent of 0, remember if I take any number to the 0 power, I'm going to get 1 as a result. And that's really important on this problem because it can save us a lot of work. It doesn't matter what is on the inside of these parentheses. Because I have an exponent of 0, my answer is just 1. Alright, next what I'd like you to do is pause the video and do number 17 on your own. Okay, so for number 17 you should get r to the negative fifth, n to the fourth, and the t's cancel out. Then you need to move this guy around and you get n to the fourth over r to the fifth. Now on number 18 we've got a lot going on. We've got some parentheses and some exponents, and we've got power over a power, then we've got some multiplication. When in doubt, follow the order of operations. So the first thing I need to do is handle everything inside of the grouping symbols. Now we have two grouping symbols, so we're just going to take it one at a time. Let's start with this first guy. 2x squared y cubed over xy squared. Now the coefficient stays put. X squared over x becomes x to the first, and y to the third over y squared becomes y to the first. Then bring down your parentheses, bring down your exponent. Now let's focus on our second guy. Again, I'm going to ignore those parentheses and that exponent, and I'm going to focus only on what's on the inside. So the coefficients, 9 over 3, that's going to simplify to 3. Now, I guess you could put a fraction bar, but I guess we don't need to. Then I have an x to the fourth over x squared, 4 minus 2, that's x squared. And then y to the third over y, 3 minus 1 is 2. So that's going to be y squared. Now, bring down your parentheses and bring down your exponent. So I've handled my grouping symbols. The next thing I want to do is I want to handle the exponents. I want to distribute the exponents throughout and get a final result. Now, I have a negative exponent here, so if you want to reciprocate and move on, that's fine. If you want to distribute and go from there, that's fine. I'm going to try like we did on number 15 and reciprocate first. Now remember, if I have a number like 4 and I want to reciprocate it, you have to remember that that's like a fraction. It's like it's over 1. So the reciprocal of 4 is 1/4. The same thing goes with 2xy. That's really like a whole fraction over 1. So if I want to reciprocate it, that's going to become 1 over 2xy to the positive second. Now I can distribute everything inside of there. I'm going to give myself a little more room here. So 1 squared is 1, 2 squared is 4, x squared is x squared, and y squared is y squared. Now let's handle this guy over here. So I'm done with this guy. This guy over here, 3x squared y squared cubed. So I'm going to take 3 to the third power, and that's going to give me 27. X squared to the third power gives me x to the sixth, and y squared to the third power gives me y to the sixth. Now I need to multiply these guys together. So remember, this is like a fraction of over 1. So really what's happening is this is going to become the numerator and this is going to become the denominator. And it's really just going to leave me with 27 x to the sixth, y to the sixth, over 4x squared y squared. Now I can simplify. I can't simplify 27 over 4, so that's going to stay 27 over 4. X to the sixth over x squared gives me x to the fourth, and y to the sixth over y squared gives me y to the fourth. On number 19, it says a lab technician draws a sample of blood. A cubic millimeter of the blood contains 22 to the third white blood cells and 22 to the fifth red blood cells. What is the ratio of white blood cells to red blood cells? Now just a reminder, a ratio is just a fraction, and they're telling us what order they want the fraction in. They said they want white blood cells to red blood cells, which means I want the number of white blood cells, which is 22 to the third white, over the number of red blood cells, 22 to the fifth red. Now we can simplify. Now if you'll notice, these have the same bases, so I can leave it with the same bases. And then I take the numerator minus the denominator, so 3 minus 5 gives me negative 2. Now that means that this is negative and that has to go to the denominator. So that's going to be 22 to the positive second, red, and then 1 white. Now all I have to do is simplify. So 22 squared, you might need your calculator for that one. 22 squared is going to give me 484. So that means there's one white blood cell for every 484 red blood cells. Now, number 20. The number of three-letter words that can be formed with the English alphabet is 26 to the third. What they really mean is combinations. They're treating like A, B, C as a word. The number of five-letter words that can be formed is 26 to the fifth. How many times more five-letter words can be formed than three-letter words? So I want the number of 5 in the numerator, so that's going to be 26 to the fifth five-letter over 26 to the third three-letter. Now I just have to simplify. So I have the same base. Then I take 5 minus 3 and I get squared. So 26 squared gives me 676. So there will be 676 more.